Dear friends, I welcome you to this lecture on transportation problem. At the end of this video, you will be able to determine the basic feasible solution for the given transportation problem by using northwest corner rule method, least cost method and Vogel's approximation method. And also you will be able to apply modified distribution method to obtain optimal solution. What is transportation problem? The transportation problems deals with optimizing the cost of transporting goods from multiple sources to multiple destinations. The main objective or the goal of transportation problem is to minimize the transportation cost by satisfying demand and supply. To understand the transportation problem better, we need to understand three key components. The first component is the source or the origin, where the goods are manufactured. Once after manufacturing, it need to be sent to the destination. The destination may be a retail store or maybe a distribution center where they wanted to sell the goods. So based on the demand at the destination, we need to send the goods from source point to destination by optimizing the cost. That is the main objective of this transportation problem. We try to solve the transportation problem by northwest corner rule method. The procedure in northwest corner rule will go like this. So it begins at the northwest corner, which is the top left cell, and then allocate the maximum possible units by satisfying the supply and demand, and adjust the supply and demand values if something is allocated. Then move to the next adjacent cell and repeat this procedure until all the demands are met. We try to solve one problem by northwest corner rule method. The problem is like this. A company operates 3 factories that supply goods to 4 warehouses. The warehouse 1, warehouse 2, warehouse 3 and warehouse 4. And 3 factories are factory 1, factory 2 and factory 3. The transportation cost per unit from each factory to each warehouse is given in the cost matrix. So this is the matrix, cost matrix from each factory to each warehouse and what is the cost of transporting. And solve the transportation problem using the northwest corner rule method to find the initial basic feasible solution and calculate the total transportation cost. Here if you properly understand the problem, here the factory 1 having units of 7 or 7 units, factory 2 having 9 units, factory 3 having 18 units, and warehouse 1 have a demand of 5 units. That may be a factory 1, factory 2 or maybe from factory 3. And again warehouse 2 required 8 units demand. Warehouse 3 required 7 units demand. Warehouse 4 required 14 units demand. And that can be supplied from unit factory 1, factory 2 or factory 3, doesn't matter, but finally the demand should be met. And if you calculate the total demand, that will be a 34, and if you calculate the total supply, that is also 34. That means the supply is equal to the demand. This type of problems are called as balanced transportation problem because here the supply is equal to the demand. So however, we need to send or the supply or the transport these units to the warehouses according to their demand. But here the other problem is, if you want to supply 5 units to warehouse 1, from which factory we need to transport, whether factory 1, factory 2 or factory 3. So usually you will say that whichever is having the less cost you will be sending. But here According to northwest corner rule method, we need to first choose in the cost matrix. This is the cost matrix, that is the 3 by 4 matrix. In this 3 by 4 matrix, whatever is at the top left corner, that cell we need to first assign. Then we need to move to the next cell. That is what the northwest corner rule method says. So finally, for each and every warehouse, it need to meet with the demand from the factories. That is what we need to solve from the northwest corner rule method. So here let us consider F1 is the factory 1, F2 factory 2, F3 is factory 3, and W1 is the warehouse 1, W2 warehouse 2, W3 warehouse 3, and W4 is the warehouse 4. And supply at each and every factory, let us say supply available at factory 1 is 7, supply available at factory 2 is 9, supply available at factory 3 is 18. So total 34. In the same manner, demand, if you see, at warehouse 1 5 demand, 2 8 demand, 3 at 7 demand, and warehouse 4 14 demand. So according to northwest corner rule method, in this matrix 3 by 4 matrix, whatever the left top corner, that corner we need to first assign. So in this cell, in this matrix, this is the first top left corner. So now if you want to assign some value here, we need to first see what is the demand for this unit, for this cell. The demand is 5, but for this cell, what is the supply available? Supply is 7. So by meeting the demand from the supply, so we need to allocate some units here. So the maximum unit we can allocate over here is 5. Even though supply 7 is available, only it required 5 units. So we need to allocate 5 units here. Once we allocate 5 units to warehouse 1, already its demand is met. So this we need not to consider when we are allocating some units to other warehouses. Hence we need to cancel this first column. So you cancel this first column. Then you observe now only 3 by 3 matrix, because warehouse 1 already met with the demand. So we already closed that column. Then out of this 3 by 3 matrix, you see what is the top left corner. The top left corner is this 30. So now how much we can able to allocate the units to this cell? This cell is having a demand of 8, but 8 we can't supply because out of 7, 5 we already given to warehouse 1. So only left out units at factory 1 is only 2. So the maximum we can able to allocate to this cell is only 2. So allocate 2 units to this cell. Then now the supply at factory 1 is already over. The supply at factory 1 is 7. That 7 we already met, 5 plus 2 7. So now this factory 1 is closed. That means whatever the goods available at factory 1 are already over. So then we need to cancel this. Then we need to see it by this 2 by 3 matrix, and out of this 3 by 2 matrix we need to see what is the top left corner, that is this corner, and now we need to assign the units to this cell. So this cell consisting a demand of 8, but out of 8, 2 already given from factory 1, but remaining 6 that we can able to assign to this the cell. So if you assign 6 here, and this entire warehouse it required 8 demand, that 8 demand we achieved from factory 1 2 units, factory 2 6 units. So warehouse 2 will be cancelled now because it already met the demand. Then we will go to the remaining 2 by 2 matrix. Now this is the 2 by 2 matrix. Out of this 2 by 2 matrix, what is the top left corner? That we will see. the top left corner will be this. So this top left corner, it is having a demand of 7. But here we need only 9 units from factory 2, but out of 9, 6 already allocated to warehouse 2, that we can't allocate again. So 9 minus 6, only 3 is available here. So then maximum we can allocate 3 units to this cell. So 3 units you allocate to this cell. Then 3 plus 6, 9. 9 units which are available at factory 2 is already supplied to warehouse 2, 6 units, warehouse 3, 3 units. Total 9 units are supplied. So this row can be cancelled. Then the remaining only these 2 cells are there. And now again if you see top left corner, 70 is the top left corner. But here this cell we can allocate only 4 because already 3 units are allocated to this warehouse 3. It has a demand of only 7. So already 3 is over. So you can maximum allocate 4 units here. So then allocate 4 units to this warehouse 3. And the remaining only one cell is left here. This one cell we can maximum allocate 14 units because the demand is 14, and also available supply also 14 because already 4 units are given to this cell. So remaining unit will be only 14. So now this is how we are going to allocate the units to the different cells starting from always northwest corner. So northwest corner, again northwest corner, like this we are going to allocate to the cells. Finally you remove all the cancelled one and keep all the allocated units in one matrix. Now if you see the entire matrix, so here 5 units are allocated, next here 2 units are allocated, 6 units are allocated here, 3 units are allocated, so 4 units, 14 units allocated. So now what is the cost of transportation? The cost of transportation is the total cost which we are using to transport these 34 units to the different 4 warehouses. But now here according to this table, 19 rupees it will cost to transport goods from factory 1 to warehouse 1. So and we are allocating only 5 units. So the cost of transporting these 5 units to warehouse 1 is 19 into 5. So then here the transporting goods from F1 to W2 is 30 rupees. We are allocating 2 units here. So the total, the cost of cost of these 2 units transporting is 30 into 2. Then the factory 1 is over. Now if you come to factory 2, so 30 is the transporting cost and 6 units we are transporting. So 30 into 6 plus, so 40 into 3 plus 70 into 4 plus 20 into 40. So if you multiply all these things and add, the total cost will come around 1015 rupees. So this is the total transportation cost by using northwest corner rule method. Let us solve the transportation problem by least cost method. Here there are 3 steps involved in solving the problem. First, identify the cell with lowest unit cost, then allocate as much as possible and adjust supply and demand accordingly. We solve this problem by using least cost method. This is also a same problem, but we are only applying the different method, that is least cost method. Initially you write the cost matrix here, and as usually this is factory 1, factory 2, factory 3, warehouse 1, 2, 3, 4, and this is the cost matrix, and these are the cells. Out of all the cells, which cell is having a least cost cell? That we need to first identify. So if you identify 8 is the least cost cell. So to this least cost cell, we need to assign or allocate the units as much as possible. So here this unit cell, if you see, it is having a demand of 8 units. That means warehouse 2 required 8 units. So we can allocate maximum of 8 units to this cell. But the supply is of 18 units is available. So first allocate 8 units to this unit cell. Then once after allocating 8 units, the warehouse 2 met the demand. So you cancel this warehouse 2 as it already met the demand. Then out of these 3 the columns, you next identify what is the next least cost unit cell. The least cost unit cell is 10. So now at 10 the demand is 14 units for the warehouse 4, but it is having a supply of only 7. So we can only assign to this unit cell 7 units. So assign 7 units. Once you assign 7 units from factory 1, 7 units only is supply. So this factory we can't further use, so cancel this factory 1. Then you see this remaining unit cells. Out of this remaining unit cell, you identify what is the next least unit cell. So this cell 20 is the next least unit cell. So to this cell, how many units we can able to assign? So see here 14 is the demand. Out of 14, already 7 was given to warehouse 4 from factory 1, but now remaining 7 only we can allocate to this cell. But already here out of 18, 8 units are gone, and here it is only 10 units is available. So demand is 7 but available supply is 10, so we can maximum allocate 7 units. If suppose if the now supply is 10, so we can able to allocate 7 comfortably. Now if you see warehouse 4, it required 14 demand. Now already 14 is allocated to this the warehouse 4. You cancel this warehouse 4. Now remaining only these 4 cells. Out of these 4 cells, next least cost is 40, and there is a 40 here also. When there are 2 places 40, first you see which one is having first any one we can start with. So now because in the sequence factory 2 will come, so let us first see factory 2, and here the maximum demand for this the unit cell is 7, but already 9 is available, so you can assign 7 here, and then this will be cancelled. Then here we can only assign 3 here because it will cancel the 3. So then remaining 7 will be coming here. So sorry, here if initially they assigned here and then gone here, the either of the way is correct only. So finally here 7 is given, but here it required 9 supply is available, only 7 is allocated. Remaining 2 we need to allocate to this cell which is left. So finally after we allocate all the units, now you remove all the hashings, then we will be seeing the solution. After removing the hashings, we will get the green colored the cells are allocated. So we will get the allocated cells and the number of units. Now if you again calculate the total transportation cost, total transportation cost you will get the cost of transportation and the number of units. So 10 into 7 and plus 70 into 2 plus 40 into 7 plus 40 into 3 plus 8 into 8 plus 20 into 7. So total if you calculate, it will be 814 rupees. Earlier in northwest corner rule method we got 1015, but here we are getting 814. By least cost method we can able to reduce the transportation cost compared with the northwest corner rule method. So let us solve same problem with Vogel's approximation method. So according to this Vogel's approximation method, first we need to calculate the penalties. The penalties are nothing but the difference between the two least costs. After we calculate the penalties, whichever the row or the column is having the highest penalty, that column or the row we will be selecting. So after selecting that column or the row, in that we will identify what is the least cost in that corresponding the row or the column. Then we will allocate to that cell. In that way, we will be allocating the units to the cells according to Vogel's approximation method. Let us try to solve this problem by Vogel's approximation method. So to solve the problem by Vogel's approximation method, first we need to write the cost matrix as usually, and this is the supply and this is the demand, and I need to first calculate the penalties. To calculate the penalties in this row, I need to first identify the least costs. So the penalty is nothing but the difference between the least costs. So here the least cost is 10. Next least cost is 19. The difference between these two least cost is nothing but the penalty. So the penalty here is 19 minus 10, that is 9 is the penalty. In the second row, the penalty will be the least cost is 30, the next least cost is 40, the difference between these two, 40 minus 30, 10 is the penalty. And the third row, the least cost is the difference between the two least costs. So least cost is 8, the next least cost is 20, 20 minus 8, the 12 is the penalty. In the same manner, for every column, we need to calculate the penalty. So again here also the penalty is the difference between least costs. So here the least cost is 19, the next least cost is 40, 40 minus 19 is the penalty in the first column. And the second column, the difference between the two least costs is the 30 minus 8, the 22 is the least cost. Then third column, the penalty is the least cost is 40, the next least cost is 50, the difference between these two is 50 minus 40, that is 10. Then least cost in fourth column is 10, the next least cost is 20, the difference between these two, the least costs are 10. So this way, first you need to calculate the penalties for each row and each column. Out of these all penalties, now we got 3 by and plus 4, 7 penalties. You identify which row or which column is having a highest penalty. So if you compare, here 12 is the highest, but when you compare with the row when you compare with the row penalties, 22 is the highest. So first you need to select the highest penalty row or column. So here the row is having a highest penalty, which is 22. That cell we need to, that column we need to select. So if it is a row, that row we will select. So because this penalty belongs to this column, so you will be selecting this column. And in this column, which cell is having a least cost, that we will identify. So 8 is the least cost, that we are going to assign the units. So to this cell we will assign the units. What is the maximum number of units we can assign? Here there is a 8 demand, but supply is 18, so we can assign total 8 units. So assign 8 units. Then once after assigning 8 units, the vertical column it meet, that means warehouse 2 it met its the demand, so you can cancel this warehouse 2. Then the remaining the units cost matrix, you need to again calculate the penalty. Let us say this penalty is called as penalty 2. So let us again now work warehouse 2 is cancelled, so again penalties will change. Let us calculate the penalties for the remaining matrix, that is 3 by 3 matrix. Again the penalty means difference between the two least costs. So here the least cost is 10, next least cost is 19, so difference between these two is 19, and here the least cost is 60 minus 40, that is 20, and here the least cost is 40 minus 20, that is 20. Again column wise if you calculate the least cost, here the least cost is 40 minus 90, that is 21, and here the least cost is 50 minus 10, 50 minus 40, that is the 10. Then here the least cost the penalty is 20 minus 10, that is 10. So this way we need to again calculate the penalty. So let us say this is called as penalty 2, and that is only for this 3 by 3 matrix. Now again you identify which column and as well as row, which one is having the highest penalty. The first column is having the highest penalty, so select this column. In this column, in this column you identify which cell is having a least cost. So the first cell is having the least cost, so assign as maximum units as possible to this cell. So here supply of 7 units are available, but the demand is only 5, so the maximum units we can assign to this cell is only 5. So assign 5 units to this cell. So then this warehouse 5 is having a warehouse 1 having only demand of 5 units, that is already given here, so we need to cancel this warehouse 1. Then again we need to calculate the penalties for the remaining matrix, that is 3 by 2 matrix. Again let us say this penalty is called as penalty 3. Again it will be the difference between these two least cost. So now only two values are there, the difference will become the penalty. So 50 minus 40, that is 40, 60 minus 40, 20, 70 minus 20, 50, and column wise if you see the penalty, that is 50 minus 40, 10, and 20 minus 10, 10. So now again we got the penalties. So out of all these penalties you identify which one is the maximum penalty. So this is having that means row 3 is having the maximum penalty, that is 50, so that we need to first assign. So in this row which cell is having the least cost? So this cell is having the least cost, so assign as maximum units as possible to this unit cell. But here already 8 is already assigned, so now maximum we can assign from here is only 10, but here there is a demand of the 14, so we can maximum demand is 14 but available supply is only 10, so what is the maximum we can assign to this unit cell is only 10, so assign 10 units to this cell. Then once after you assign this cell, this row 3, that means a factory 3 will be closed, because the total demand is, the supply is only 18, that 18 already we assigned to warehouse 2 and 4. Then again you close this warehouse 3, then you see the remaining the units. The remaining matrix is only 2 by 2 matrix. Again you calculate penalties for this 2 by 2 matrix. So now if you calculate, again it becomes a 40 and here it becomes a 20, but if you calculate penalty 4, the penalty 4 will be 40 and here 20, and here it will be 50 minus 40, 10, and then here the 60 minus 10, it is 50. That means we need to select the column 3. In this column, what is the least cost cell? The least cost cell is this, that is 10. So assign as maximum as possible to this cell. So here actually demand 14, but a supply is 7 is available, but out of 7 the 5 is already assigned to this, so only 2 is available. Here 4 demand is there, but maximum we can assign to this cell is only 2, so 2 we assign. Then once a 2 is assigned, 5 plus 2 7, factory 1 it is already meeting the supply, so the factory 1 will be closed. Then factory 1 is closed, then only one another row will be left. In this row we need to see which one is having the least cost, the 40 we can assign the values. So here the demand of 7 units are available, but the supply of 9 units is available. We can assign 7 units to this 40 cell. Then the 2 units will be left from this factory 2 supply, so you remaining 2 units you can assign to the unit cell of 60. So now if you see total supply and the demand, we already allocated the cells or units. Then we need to calculate the total cost. Now if you remove the hashing, so this is the final allocation. So here the green letter units are the cost of unit cell, and these are the units. So now if you calculate the total transportation cost, 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10. Now if you calculate the total, it will be 779, which is less than the cost of the least cost method, and it is also less than the cost of northwest corner rule method. In this way the problems will be solved by using a Vogel's approximation method. Next method is modified distribution method. This also called as Modi method. Generally this Modi method will not solve the problem, but it is used only for optimization. So according to this Modi method or modified distribution method, initially the basic feasible solution need to obtain. After obtaining this basic feasible solution, then write the cost matrix for only the allocated cells, and if this allocated cells is equal to m plus n minus 1, then only the Modi method or the modified distribution method is applicable, where m is nothing but the number of rows, n is nothing but the number of columns minus 1. And then the third step is calculate the ui and vj values for each row and column. And ui and vj, these values I will tell you while solving the problems. And fill out the vacant cells using vi plus vj. Then compute the net evaluation, that is delta ij, that is equal to cij minus ui plus vj. If all delta ij is greater than or is equal to 0, an optimal solution has been arrived. After you arrived this delta ij values are greater than 0, we can't further do the optimization. So our problem will end there itself. So let us solve this problem. So this problem says solve the transportation problem using the Vogel's approximation method to find the initial basic feasible solution, and then check the optimality using the modified distribution method to further minimize the total transportation cost. So here the modified distribution method is used only for optimality test. So initially obtain the basic feasible solution by any one method. So here they already mentioned the Vogel's approximation method to find the basic feasible solution. So we are directly writing the solution for Vogel's approximation method, because this solution is same as before. So we are directly taking the allocations from the previous problem. So once after you obtain this basic feasible solution, the next step is write cost matrix for only the allocated cells. Here these are the allocated cells, and write the cost matrix for only these allocated cells. And if you count the allocated cells, those are 1, 2, 3, 4, 5 and 6. 6 allocated cells are there, and these 6 should be equal to m plus n minus 1. So where m is nothing but the number of rows and n is the number of columns. So here the number of rows are 1, 2, 3. Number of columns are 1, 2, 3, 4. So columns are 4. So m plus n minus 1 is equal to 3 plus 4 minus 1, that is equal to 6. So here the allocated cells are is equal to m plus n minus 1. So optimality test can be applied to this problem. So now in order to solve this problem, you assume that this is the cost matrix, allocated cost matrix, and you assume that this is the u1 and u2, u3, and here this is the v1, v2, v3 and v4. So these u1, u2, u3, v1, v2, v3 and v4 we are assuming in order to calculate the delta ij. So here we are also assuming that 19 is the allocated cell, that is equal to which is u1 plus v1. So that way we obtain this equation. So denote rows and columns by this assumption, that is u1 plus v1 is equal to 19, and here this is allocated cell again. So this is 10 is equal to u1 plus v4. So you will get another equation. Again you assume this 40 is equal to u2 plus v3. You will get another equation. 60 is equal to u2 plus v4. So then you get another equation. And here 8 is equal to u3 plus v2. So that is equal to 8. Then last 20 is equal to u3 plus v4. So this way we got some set of equation. This equation if you solve, you will get this u1, u2, u3, v1, v2, v3 and v4 values. And these v1 and v2 or v3, v4 and u1, u2, u3 values are required to calculate a delta ij. And u1, u2, u3, this also can be called as ui, because I indicates the row values, j indicates the column value, u1 means this one, u2 means this one. So that way we will be denoting the values. Now let us solve the values from the equation. So calculate u1, u2, u3, and v1, v2, v3 and v4 by using this equation. Now if you how we can solve without having any value? So we can't solve because any one value we should be knowing. So first consider either u1 or v1 is equal to 0. So now I am considering that u1 is equal to 0. If u1 is equal to 0, v1 value will become 90. So here this is the u1, so that I am considering as 0, then the v1 value will become 90. Then once you get a v1 value and u1 is 0 here, again u2, u1 value is 0, so u4 value you will get a 10. So u4 cell is this, you write the value here. Then you also got v4 value. So if you go to v4 cell here, so v4 cell, v4 is equal to 10. So if you substitute v4 value here in this equation, u2 you will get u2 is equal to 40 minus 60 minus v4, v4 is 10, 60 minus 10, 50. So you are getting a u2 value as 50. Then here if you apply the v4 value to this cell, and that is u3 plus v4, v4 is equal to 10, then u3 will be equal to 20 minus 10. That means u3 is equal to 10. So that 10 you can write here. Now how many values we got? We got u1 0, the u2 50, u3 10, and again we also got v1 19, v4 10. Then we want v2 value. So you go to where is v2, in which equation? So in this equation the u3 plus v2 is there. So v2, so v2 we don't know, u3 is 10. So if you substitute, the u3 is equal to 10, so 10 plus v2 is equal to 8. So then v2 is equal to 8 minus 10, that is equal to minus 2. So v2 value you can able to write here. Then you want v3 value. v3 value, so this is the equation for v3. So that is u2 plus v3 is equal to 40, u2 value is 50. So v3 is equal to 40 minus 50, that becomes minus 10. So this v3 value will become minus 10. So this is how we will achieve u1, u2, u3 as well as v1, v2, v3 and v4 values. So once after you get all these values, so with the allocated cells, then we will go further. So now fill the vacant cells using ui plus vj. These are the allocated cells and these are the vacant cells. So these vacant cells you fill with ui plus vj. That means, so this cell is belongs to u1 plus v2. So if you add these two, this will get. So if you add these two, 0 plus of minus 2, this becomes a minus 2. This cell value will become 0 plus of minus 10, so it becomes minus 10. And this we are not allocating because it is already allocated, so we are not calculating ui plus vj value here. Even this all dots indicates that these are the allocated cells. Again here if you come, so here it is u2 value 50 and v1 value 19. So u2 plus v1, that is equal to 50 plus 19, that is 69. Again this cell 50 minus 2, 48, and these two I can't assign. And here this cell if you go 10 plus 19, so it is 29, and in this cell 10 minus 10, it becomes a 0. So this is how you will get the unit cell values with ui plus vj. Then after you get this ui plus vj values, now you calculate delta ij. Delta ij is equal to Cij minus ui plus vj. So ui plus vj table is this, so which we got in the previous slide. And here Cij is nothing but the initial cost matrix. In the cost matrix, what are the cells? But in this cost matrix, wherever there are the allocated cells, that allocated cells we are not taking. We are only considering the unallocated cells. So in unallocated cells, Cij values are given according to the problem like this. And these are the ui plus vj value. Now delta ij I can easily calculate by minusing Cij minus ui plus vj. This is the Cij values and this is the ui plus vj value. So this table minus this table will give you delta ij value. So here this is the first table indicates Cij, second table indicates ui plus vj. So this third table indicates delta ij. So delta ij is equal to Cij minus ui plus vj. So that means the values in this table minus values in this table, except these are the supply and demand that we will not be subtracting. This is only for calculating the ui and vj. Then if you see the first cell, that is allocated, so we will not modify anything there. Then the next cell is 30 minus of minus 2. So this table minus this table, so 30 minus of minus, so it becomes a 32. So sorry, it is 32. And 50 minus of minus, so it becomes a minus of minus, so it becomes a 60. This is also 60, sorry. And then this 70 minus 69, so this becomes how much it is? 70 minus it becomes 1. And 30 minus 48, it becomes minus 18. And then these are allocated cells and this is unallocated. This is 40 minus 29, so that is 11. And this is allocated cell, this is 0, so 70 minus 0, 0. So if you observe this delta ij value according to this modified distribution method, if delta ij is equal to is greater than or equal to 0, then optimal solution has been arrived. But here if you observe all this matrix, so all values are positive except this 18. So which indicates that at 18 minus 18 we need to allocate some cells, we need to allocate some units to this cell such that we can able to achieve the optimality. So we need to allocate some units to this cell. How much we can able to allocate? Again we need to go to the basic feasible solution. If you go to the basic feasible solution, this is the basic feasible solution according to this the previous matrix according to modified distribution method. This units, this cell, we need to assign some units. How much we can able to assign? So now if I want to assign some units to this, if suppose if I assign 9 units to this, so already 7 plus 2, 9 already assigned to these two cells, that I need to drag here. If I shift these values here, again this warehouse 4 will have unbalance again because it has the 8 demand and already 8 we given. So we need to again subtract from here. So that way we need to assign some values to here, which will be possible value which we can able to assign to this cell. So what is the possible value we can able to assign to this cell? So now first we will see. Let me think about the next cell. So if I bring this 7 over here, then what will happen? This 7 if I bring, so this warehouse will have a deficit. So if this warehouse has deficit, so I need to move some more values over here. But to move some values, 7 values here, there is no allocation to this cell. So I can't move this 7 over here. So that is why whenever we are for moving any cell is we are selecting, we need to see the total allocations are again balanced. Now if you see next cell, here maximum 2 are there. If I allocate this 2 or move this 2 to this cell, then there won't be any balance here because again 2 will be allocated here, 7 will be there, and here if 2 is there it will become 11. So I need to subtract this 2 over here. Then if I subtract it again, this column will have the deficit. Again I need to add some values over here. If I add some values here, again I need to reduce some values here in order to balance this. Then if I reduce it, I can add this here so that the vertical column and horizontal column will become balanced. Now that means how much maximum I can able to add. So I can add maximum, that means if I am adding some values to this cell, that should be able to subtract to this allocated cell and also subtract from this allocated cells, and also we can able to add over here. So it will be going like this. If we are adding theta units over here, and here it will be this value minus theta, and it will becomes this value plus theta, and in this it will become this value minus theta. So now what is the maximum value we can able to assign to this cell? the maximum value we can able to assign here is only 2. So if you assign 2 here, what will happen? 2 is assigned here, then 60 minus 60, 2 units are already there, 2 minus 2, it becomes a 0. Then only this the row will be balanced. So if this becomes a 0, 10 plus 2, it is only 12. So I need to make plus here. So 10 plus 2, it becomes a 12. If I become 12, it becomes a 12. 12 plus 8, it is becoming 18. So this 8 also I need to change it to 8 minus 2. It becomes a 6. Now you see this row should have 18 supply. So 6 plus 12, 18. And this warehouse 4, it should be 12 plus 2, 14. So again here in this second row, so 2 plus 7, 9. And in this first second warehouse, again 6 plus 2, 18. So all supply are satisfied, all the demands are satisfied. So this is how I can able to relocate this assignment 2 units from 60 to 2. Then I will get the optimum feasible solution. Now how to calculate the transportation cost? Again the transportation cost is equal to 19 into 5 plus 10 into 2 plus 30 into 2 plus 40 into 7 plus of course it is 0, it becomes 0, 8 plus 6 plus 20 plus 12. So it will be 743 cost. So compare with the previous problem, this is giving less cost. Let us solve one more problem. A company operates 3 factories that supply goods to 4 warehouses. It is similar to previous problem, but only thing is some values are changed. So here the factory to warehouses, some values are given. So these values are changed. That means cost matrix has been changed. Now for this new problem, let us solve the solution by Vogel's approximation method and find the initial basic feasible solution and check the optimality using modified distribution method. So first we will calculate we will find the initial basic feasible solution. So if you obtain the basic feasible solution by VAM or Vogel's approximation method, the basic feasible solution will be like this. So once after you get this basic feasible solution, then the next the procedure is write the cost matrix for only allocated cells. So here the allocated cells are 2, 1, 6, 2, 4 and 1. And again here like earlier you need to assume that this is the U1, U2, U3 and V1, V2, V3 and V4. So now we need to denote the equations. So now you consider 2 is equal to U1 plus V1. So in that way you write the rows and columns and you denote the values. So in that way if you write, so this 2 will be equal to U1 plus V1 and then this 1 is equal to U1 plus V4. That way, because there are 6 allocations, you will get 6 equation. So to solve this equation initially we need to assume that either U1 or V1 is equal to 0. So by considering U1 or V1 is equal to 0, you calculate other values. Now if suppose if you assume U1 is equal to 0 and V1 will become 2. So how it will be 1 here? So it becomes a 0, then it will become a 2. So then, and if this becomes a 2, so these values are little mistakes are there. So sorry, it is oh no, sorry, I think they assume U4 is equal to 0, then this will become 1. So anyone we can able to assume is equal to 0. So here they assumed that U4 is equal to 0. If U4 becomes 0, U1 will become 1. So this becomes 1. So if it becomes 1 and you substitute here, it becomes 1 and 1 plus V1 is equal to 2. So V1 will become 2 minus 1. It becomes 1. So then in that way again here you got 1, that is u1 and v1. So v1 if you substitute here, and v4 becomes 0, and v1, where is another v1? v1 is here, u1 is here, and u4, if u4 becomes 0 here, u2 becomes 6. So u2 becomes 6, and if v4 becomes 0 and u3 becomes 2. So why I consider u4 is equal to 0? Because u4 is at many places, so that I assumed that it is 0. Then so this becomes a 1, 6 and 2. Then I want these two values, that is v2. v2 is equal to v2 plus u3 is equal to 1. So u3 again now how much? It is already u3 2. 2 is 2 plus v2 is equal to 1, and v2 is equal to 1 minus 2, it becomes a minus 1. Then I want a v3. So v3 is here, u2 plus v3 is equal to 4. So now you substitute the u2 value, u2 is equal to 6, and v3 is equal to 4 minus u2 is equal to 6. So 4 minus 6, it becomes minus 2. This way I am now obtaining u1, now u2, u3, v1, v2, v3 and v4 values. Now these are the allocated cells. For unallocated cells you write vi plus vj matrix. So if I write u1 ui plus vj matrix, so this becomes 1 minus 1, so it becomes 0. This becomes 1 minus 2, it becomes minus 1, and this cell will become 6 plus 1 7. This cell becomes 6 minus 1 5. This cell will become 2 plus 1 3, and this will become 2 minus 2 0. So I got all unallocated cells values. Now in the same manner, this matrix is called as a ui plus vj matrix. Similarly now you write a uij matrix. uij matrix is the matrix, initial matrix, where the unallocated cells are there. So these are the unallocated cells. So this is becoming a Cij matrix, and this is the ui plus vj matrix. Now let us calculate the delta ij matrix. If I calculate delta ij matrix, that is equal to Cij minus ui plus vj. So this matrix is ui plus vj matrix, and this matrix is Cij matrix. So delta ij is equal to Cij minus ui plus vj. So this matrix minus this matrix will give the delta ij. So now if you do that, 3 minus 0 0, 5 minus of minus 1, it becomes 6, and this becomes a 7 minus of 0, so it becomes 7. So 3 minus 5, it becomes a 2. So then here 4 minus 3, it becomes 1. 7 minus 0, 7. So this is the new matrix of delta ij. If you identify or observe all the values, so except this value, all other values are the non-zeros are greater than or equal to 0. Greater than or equal to 0. So because there is minus value, it promotes that this cell need to be assigned with some units. So it should not be empty. So how much possible values we can able to assign to this cell, that we need to assign. So again we will go to the basic feasible solution, and this is the basic feasible solution, and according to this the modified distribution method, it is proposing that here some units should be assigned. Again if you compare what are the maximum units we can able to assign here, so here I can't take it from 7 because there is no value here, because whenever you are taking some value, it should cover a rectangular manner or square manner, such that if you are deducting some value here, that should be added here, and that should be again making minus. So here I can maximum allocate 2 units, because the maximum values which are here is only 2. So 8 I can take it but what is the problem is I can't add 8 here again, so I can't subtract 8 here. So that is why the maximum out of these two corners, maximum value which I can move from this side is only I can able to move. So this 2 I can move here, so then this becomes 2 minus 2 0, and this value will become 2 you assign here first, then you minus 2 it becomes 0, and then here the 10 plus 2, because here I minused, so now it is unbalanced. 10 plus 2 only 12, so I need to make plus 10 plus 2, it becomes 12. Then again it becomes unbalanced, so here I need to minus 2 values, 2 units, so 8 minus 2, that is 6. Now it becomes a balanced. So finally the basic feasible solution for this problem is final minimized total transportation cost is the 2 into 5 plus 1 into 2 plus 3 into 2 plus 4 into 7 plus 6 into 0 plus the 1 into 6 plus 2 into 12. So total 76. It is the total transportation cost. So that is the solution. In this way, the MODI method will be used for optimality test. Finally, I would like to conclude that transportation problem will optimize the transportation cost by satisfying the demand and supply. And here we saw that the three methods which will give the basic feasible solution. These three methods are northwest corner rule method, least cost method, and Vogel's approximation method. And again we also saw that the modified distribution method which we will be using for optimality test. Thank you.